Right, we looked at pure premium, office premium, prospective, retrospective reserve. So now we're going to look at mortality profit and asset share. Under this topic, we've also got things like death strain and expected death strain and stuff like that. So without further ado, what we're going to start by doing is looking at a sort of simplified version of how we roll forward the reserves from one point in time to the next. So there is a whole load of very technical notation about reserves, but all we really need to do is develop this sort of generic notation for the reserve for policy issued to a life aged X, T years into running the policy. So that's what that reserve means. Okay, so that's the reserve, whether it's prospective or retrospective, because we get the same thing in terms of the pure premium basis. That's the reserve we have after T years. And then what happens at the start of the Tth year? We get the premium. Okay. Then over the year, we get a return of I. At the end of the year, that's either going to pay out the benefit if there's a death, or it's going to go and contribute to be next year's reserve if there's not a death. Okay, so we're assuming in this case that the sum assured is 1. It's a sort of unit case. So the value of the death benefit is Q X plus T. Now just be careful with that. This was issued to life age X. We're T years into that life, and this is what happens over the year T to T plus 1. The probability of death in that year is QX plus T. But the amount of this fund must pay for not just the death benefit, but also the reserve for the next year. And there's a probability of Px plus T that we need that reserve, because we won't need any reserve if they die. And that is then the reserve at the start of the next year. Okay? So that's how we calculate how we move the reserve from one year to the next. So there's two different things that can happen here. We can either have a death or not a death, and we make a profit or not. If we have a term assurance and there are no deaths, we make a profit. If there are lots of deaths, we make a loss. So there's something called death strain, or in quote the technical term, DSAR, death strain at risk. And the death strain at risk is how much more expensive it will be for there to be a death than for there not to be a death. Okay, so in this case, the death strain at risk equals 1 minus T plus 1 Vx. The reason for that is that if there's a death, we pay out 1. If there's not a death, we have to contribute this amount into next year's reserve. So it's only actually cost us 1 minus the reserves we will need. Okay, because if the death happens, we won't need any reserves. So the cost of this death is 1 minus the reserve we will need if there's not a death. Okay, so then we have something called the expected death strain, okay, which is Q of X plus T. So the probability that the death strain happens, 1 minus T plus 1 Vx. Okay, we then have something called the actual death strain. The actual death strain is the actual number of deaths that actually occur in the sample. Okay, so if we have, for example, so it's the actual realized death strain. Now in this case, it's either going to be 1 minus T plus 1V, okay, if there's a death, or 0 if there's not a death. Okay. And it makes slightly more sense, or it just feels more natural if we just have a lot of policies do this, because if it's one policy, then it kind of, I mean, you're expecting out of 1,000 policies to be a few deaths sort of thing. So if it's one policy, you're expecting 0 deaths, which is a bit weird. So we really, although expected death strain and actual death strain are defined, perfectly defined concepts with a cohort of 1 life, it makes slightly more sense to look at it in terms of multiple lives. Okay, so let's say there is n lives at term t. Okay, then the expected death strain is equal to n qx plus t over 1 minus t plus 1 vx into 1 minus t plus 1 vx. Okay, and the actual death strain equals the actual number of deaths. Okay, so the n lives at term t, and there are d deaths in year t to t plus 1. So the actual death strain is d times 1 minus t plus 1 vx. Okay, and if the actual death strain is less than the expected death strain, then we make a profit. So the mortality profit is equal to, we'll make a profit if the expected death strain is greater than the actual death strain. So it's the expected death strain minus the actual death strain, which is 1 minus t plus 1 vx times n q x plus t minus d. Okay, don't offer, I mean, I wouldn't bother learning that formula, because what I've done here, okay, I've assumed all the policies have sum assured 1. Okay, so it's just worth noting here. Assumed all policies have sum assured equals 1. We often make that assumption when it's one policy because we can just multiply it up, but in reality there's going to be multiple different policies with multiple different sum assureds. So this here, and you can work it out for yourself fairly easily, but the expected death strain becomes instead of nq 1 minus t 1 minus v, it will become the sum of qx plus t times, let me think about that, basically it becomes the sum of the expected death strain for each individual policy. Okay, so we'd go back to the expected death strain for one policy, and we just take the sum of the actual of those death strains. So we have the sigma there, and si, where I goes from 1 to n, where s is the sum assured. Okay, and the same thing with the actual death strain. Again, we just take the sum of the s's minus that for the actual deaths, and 0 for the non-deaths. So the algebra becomes slightly more complicated when you've got different sum assures for each life. But that's not a sort of conceptually difficult extension. Okay, so that's this topic of actual death strain, expected death strain, mortality profit, and death strain at risk. And it's a relatively straightforward concept. Just be careful. The danger is you get death strain confused with mortality profit. Mortality profit is the more natural concept. It could be better than you're expecting, in which case it's a profit. It could be worse than you're expecting, in which case it's a loss. But death strain is always a negative. Okay, there isn't like a positive death strain, unless it's an annuity or something, which you have to think about slightly differently. We should also mention at this point the concept of asset share, which we haven't mentioned yet. Asset share is closely related to mortality profit and the rest of it. Asset share is simply the practical amount of actual reserves you have. Okay, so so if your prospective reserve is equal to 2 million and you made a mortality profit of 250,000, then your asset share is 2.25 million. That is also impacted by changing interest rates and stuff like that, but asset share is basically, given the mortality won't be the same as in the basis that you're assuming, it's how much money you've actually got in respect of that policy. Okay, so it's related, it's the practical version of prospective or retrospective reserve. And that's all asset share really is.